We are live. This is Math 40. This is section 1.9 part 2. And we are combining like terms. Woohoo! Yay! Now, I think once you get the hang of it, this section of 1.9 is actually way easier than the first part. But again, if you're a little rusty, if it's been a long time, or if you've actually never learned this might feel a little weird. So beginning with the kind of randomly weird English that is combining like terms. So like terms is not just a Californian thing, like terms, totally. It's actually like as in similar or the same. So when we say they're like terms, they're similar or the same, what does that mean? Well, if I have 2x and 4x, those are like terms. They both have x's. Even though the numbers don't match, the variables match. Unlike terms, well, 2x and 4y. Those don't have the same variables. Okay, how about 2x and negative 17x? Yes, those are like terms because the variables match. What about 2x and negative 17x squared? Nope. These don't match. These don't match. The variables don't match. And I hear you say, wait, but this has x's. It's just like x and x squared. They're the same, right? And the answer is yes, they both have x's, but they are not the same. And in fact, because I've studied a bunch of math, I know that where we're headed to in math, what's going to be most useful is that we can recognize when the variables match exactly. So could it be 6xyz squared? Sure. But then your other number better be, let's see, I need a number, negative 8xyz squared. See how the variables, I've been using a lot of blue, the variables match exactly. So as long as the variables match exactly, that's like terms. Okay, so now I'm going to do something very strange. I'm going to add 3x plus 4x using the distributive property. And I'm going to do it, and a lot of people are going to be like, what are you even doing? And that's okay. Do you remember the distributive property? I'm going to go backwards. I'm going to say if there's an x here and there's an x here, it's basically kind of like there was an x outside and we took it visiting the family. So if I go backwards, if there's an x here and an x here, I could say x went to go visit 3 and then x went to go visit 4. So I write it using the distributive property. And spoilers, going from this step to this step, so going backwards, is going to be called factoring later on. Right now, we're just going to say, wow, that's weird. And I'm going to say yes, but then notice what happens. What's 3 plus 4? It's actually 7. What's x times 7? Well, I can use the commutative property and say that's 7x. All of this is a very fancy way of saying, you know what? You're allowed to add, as long as the variables match exactly, you can add them like you would add puppies. 3 puppies plus 4 puppies equals 7 puppies. So the question is, can you add puppies and cats? So if I had 3 puppies but 4 cats, you can't really add them together. You'd have to say like 7 pets. You'd have to change the whole problem, talk about something completely different. So the 2 things have to match. The puppies have to match or the x's have to match. Okay, so let's give some a try. It's okay if you don't get them right to begin with. This is learning, right? So combining like terms. 9z minus 7. Okay, we're starting right off. Let me make it big. And I'll remind you that I put a little dash in my z's, which I know is a little weird. It's unusual, I should say. And the reason I do it is because if I don't, my z's and my 2's look just like each other. They're very hard to tell apart. So I put a line through my z. Some people use it, some people don't. It's up to you. I got z's, I got numbers. There are no like terms. And these are not like terms. So I say this is already simplified. That's the answer. This is already simplified. I cannot simplify it any further. I can't smash them together. They don't go together. They don't match. Okay. How about dun dun dun? This one's a little more complicated. Let me write it big. I got 9z minus 7 minus z. Whoa, quite a lot going on. 3 terms, right? And I see a z here and a z here. And then I happen to remember there was something about a commutative property. It says, now you're saying, wait. You can't have commutative property with minuses. And I'll say, aha, there's a trick. Here's the trick. Have this z pack up the minus and pull it all together. So what do I mean? Have this whole minus z move so that it sits right there. As long as you move the minus with it, you're golden. Okay, I've got 9 z's. Someone took one of them, az. 9z minus z. How many z's do I have? So if I had 9 puppies, oh my gosh, how cute would that be? 9 puppies, and one of them went to go live with someone else. How many puppies do I have left? You got it. I've got 8 puppies. The minus 7 just hangs out. What do you guys think? It was a little intense. Okay, just breathe. Think about puppies. Think about the Bat Brothers, how cute they are. Okay, we're going to take it to the next step. 9z minus 7 minus z minus 19z. Oh my gosh. So I'm going to rewrite it. I'm going to say it's 9z. I'm going to take the minus z, move it up here. I'm going to take the minus 19, negative 19z, put it there. And the minus 7 is going to go at the very end. What do you guys think? So do you see what I did? I took that minus 7 that wasn't matching with anyone. And don't feel bad. He doesn't feel bad. He actually, I spoke to this minus 7 and he really likes to be alone. You know, he needs some time. And so he's totally cool to be at the end. Everybody's happy. The numbers don't sweat it. But now I have to figure out how to add all of these together. Now, what was the rule? The rule was, and there are minuses, but as long as I think of it as 9z plus the opposite of z plus negative 19z, it is addition, and I can do it in any order I'd like. I got 9 of these. I got 9 puppies. Then one got given away, so I'm down to 8. And then I have 19 friends who want puppies. So what is 8 minus 19? I think this is what, negative 11z minus 7? What do you think? Kind of woohoo? I can actually feel through the monitor that some people are like, I don't know that I think this is right. And I would say, well, I really appreciate you having faith in me that we will get to something that will make sense. Fingers crossed. Dun, dun, dun. Let's try some more problems. What if I had 43 43s cubes, and I want to subtract 44s cubes. So I had 43 puppies. Or these aren't puppies, these are cats. Let's do cats. 43 cats. And I have 44 friends who want a cat. What do I do? Well, 43 minus 44 is -1. And then I'll remind you that when we get a -1 in front of something, we just write it as a minus something. You don't write the ones in usually. Sometimes you do. I know it's like, oh, there's so many rules. And the answer is, that's why I'm doing videos. You watch me do math and you slowly learn through all these weird little details. What do you guys think? Kind of woohoo? Okay, now what about number 5? 43s to the 4th minus 44s cubed. I have 43 flamingos, and my friends want to adopt 44 cats. What do I do? And the answer is, you have to call up your friends and say, you have flamingos, you don't have cats. You say, this is already simplified. I can't do anything because these aren't like terms. These are not the same. This is describing s to the 4th. This is describing s cubed. They're not the same. Okay. Put a box around this one. 2 boxes make me feel good. Okay. Now we're going to switch gears a little bit because at this point, we've done a lot of shortcuts and I want to make sure that I'm really clear about what the shortcuts are. So if I take an x and I add another x, I've got one x and I add another x. How many x's do I have? Got one here and one here. Altogether, I've got 2x. So far, so good? Okay. What if I have an x and I multiply it times another x? Do I have 2x? And the answer is no. An x times an x, which you can write with implicit multiplication if you prefer, is x squared. So take a look at those, especially when folks are starting up again. It's been a while since you've done algebra. These two get switched around. So if you're adding 2 x's, you get 2x. If you're multiplying, you get into exponent land. What about x plus x plus x? If you're adding, you're counting them up. I've got an x and another x and another x. Altogether, I have, you got it, 3 x's. So far, so good? Yes. Okay. Number 4, I have 2 x's, and I add another x, and I add a 5. Do I have any like terms? I do. The 2x and the x are like terms. So altogether, I have 2 x's plus another x, which gives me 1 plus 2 is 3. 3 x's plus 5. Now, can I add these two together and get 8? And the answer is no. You stop here because this 3 is describing x, and this 5 is just by itself. It's not 5x, it's just 5. 3x and 5, they can't be combined. Can I say, I said, well, I've got 3 dogs sitting here with me and 5 rutabagas. Can I add them together? And the answer is no. Dogs and rutabagas, not the same thing. I know it's confusing, but try to keep them straight, because that's important. Okay, next up. 6x minus y plus 2y minus 3x minus 12. Well, you know what I'm going to use. I'm going to use the commutative property because there's too much stuff running around. I got x's. So let me find all the x's. I got a 6x and I got a minus 3x right there. I want to bring those bad boys together. 6x minus 3x. Okay, so I got those taken care of. Woohoo! Ooh, listen to me. I got the vocal fry tonight, mostly because I'm tired. I got a minus y and a plus 2y. Minus y plus 2y. Okay, those are my y's. They were all right together. I just kind of bring them down. And again, there's a minus 12. Don't feel bad at it for it. Don't cry for negative 12, Argentina or anyone else. The number likes to be by itself. It's thinking deep thoughts, writing really great, terrible poetry. I had 6x. Someone took 3 of them. If I have 6 x's and someone took 3 of them, 6 minus 3 is 3x. I owed someone a y, and then I got 2 more y's. A negative 1 plus 2 is plus 1y. And then the minus 12 just hangs out. And again, I'm going to make this look pretty. 3x plus y minus 12, so we can be totally cool like the cool kids. Yeah, we don't write the ones in front of our variables because we don't need to. Think lazy. Think mathematicians are trying to keep from having to write anything extra. Draw the little visual line there. Here's my final answer. Okay, you guys ready? So I'm going to write this big. 3z minus y squared plus 2y minus 10z minus 4y plus 3. What I'm hoping you guys will do is pause the video, work this out, start the video up again, because in class I would say, okay, everyone, give this one a try, because this one is the big finish for this section. Now, are we going to get more practice? Oh my gosh, yes. We are going to practice and practice and practice and practice. That's what algebra is. It's just a lot of practicing. The goal is that you get so comfortable with the algebra that you could start doing some really cool things with it, like trigonometry or economics or even calculus. So we're going to practice. But what I'm hoping you can do is let's practice this right now. So pause the video. And as you're thinking about it, if you're thinking, oh, do I have to use highlighters? No. Oh my gosh, no. If you hate this, don't do it. That's no fun. Don't do it. If you want to try to do it in your head, go for it. But make sure you're also able to write it down. So go ahead and pause it. I can pretend it's paused. I'm frozen. Okay, are you done? Good. Okay, let's start it up again. Woohoo! So I think I'm gonna need all of my highlighters. Z's. Do I have any other Z's? I do. Okay, those are my Z's. I'm gonna use let's see how to purple. Ha-ha! Y squared is purple. Now, y squared is sad. Y squared does not have a friend. Now, there is a y, but remember y and y squared are not like terms. Okay, who else do I have? I've got this y. Any other y's? Yep, this y. And then the last one that I have, and I'm going to have to reuse a color. Go ahead and use, oh, that's too close to the orange. I'll use the blue then. And the 3 by itself. Okay, so let's go with the z's first. I've got 3z, just because I started with the 3z, minus 10z. And what is the name of the property that lets me move stuff around as long as I hold on to my minus? It's called the, you got it, commutative property. I know it should be the commutative property, but yeah, no one talks to mathematicians, so math doesn't change linguistically, sadly enough. The y squared is just kind of hanging out. It doesn't, I didn't bring anyone to the party. That's okay, it's having a good time. Okay, then I've got the 2y minus the 4y. Right, I bring in the 2y minus the 4y. And the last thing I bring in is this plus 3. Now, you know me, or at least you know my hands. And my hands, along with the rest of me, have a lot of issues with writing things down, mixing things up. So what sort of things do I do to try to keep myself from really just being silly and being embarrassed about the videos? Well, 1, I don't watch the videos. That's helpful. But 2, I also count. I've got 1, 2, 3, 4, 5, 6 terms Down here, I've got 1, 2, 3, 4, 5, 6 terms. 2 yellows, yep. 1 purple, yep. 2 oranges, yep. And a blue. So both the colors and the numbers help me make sure I don't skip one. Don't leave one out. Okay, so let's combine 3z minus, so I had $3 and I spent $10, which means I owe someone $7, 7z. The minus y squared just hangs out. 2y minus 4y, I had 2, I spent 4, that's a minus 2y, plus 3. Wow, I was in a really negative mood when I wrote all these problems, huh? Almost as if I'm trying to help you practice with your negatives. I don't know. Or maybe there's no good reason. Okay, negative 7z minus y squared minus 2y plus 3. You guys are amazing and awesome. This was a couple of really heavy videos. Take a break, get something to eat, get a little sleep, get some exercise, go pet an animal if you've got one. Go snuggle a blanket or a stuffed animal if you've got one. This is the end of chapter 1. Next up, we go to chapter 2. So we start some new stuff. And I'm very excited. I hope you're very excited. Woohoo, math. And I'll see you guys in the next video. Yay! Yay, math.